Welcome children, take out your geography book. Today's topic is pressure wells, winds. Atmospheric pressure and winds. Introduction. We are surrounded by air on earth, but we do not see it. Yet we can feel the pressure of air. Thus, air pressure and winds are invisible elements of weather which influence other components of weather, temperature and humidity. The variations in the air pressure place to place occurs due to differential heating of the atmosphere. This causes the movement of winds which serve as means of transporting heat and moisture from one region to another. Thus, air pressure is crucial to all forms of life on earth as it plays a dominant role through its control over temperature variation and precipitation. Concept of air pressure. Like any other material object, the air also has weight. One can feel it while driving or walking against the wind. This is because air is a mixture of gases. Gas molecules are in constant state of collision and move freely. If we keep our gas in a closed vessel, its movement is restricted by walls of the vessel. Thus, gas molecules exert an outward push as they dash against the container. Similarly, the atmosphere may be deemed to be a closed container bounded by the land and sea from below and force of gravity from above and does not allow air to escape to outer space. Air pressure therefore can be defined as the force exerted against the surface by continuous collision of gas molecules. The amount of pressure exerted by air at a particular point is determined by two factors, temperature and density. Since air pressure is proportional to density as well as temperature, it follows that a change in either temperature or density will cause a corresponding change in the pressure. It can be described as pressure is equal to density multiplied temperature multiplied constant. Therefore, an increase in either density or temperature will cause an increase in pressure provided the other variable remains constant. The atmosphere exerts a pressure of 1034 gram per square centimeter at sea level. This amount of pressure is exerted by the atmosphere at sea level on all human beings, plants, animals, rocks, etc. We do not feel the atmospheric pressure because the air inside us exerts an equal amount of outward pressure, balancing the inward pressure of atmosphere. Air pressure decreases with increasing altitude and at a certain height this balance is disturbed, resulting in marked psychological disturbances such as nose bleeding, ear bleeding, etc. The mountaineers have to face a lot of difficulty because of much reduced atmospheric pressure at great height. This is so because the higher we go, thinner becomes the atmosphere. The molecules in the high altitude are more diffused and pressure reduces. The atmospheric pressure is measured more accurately with the help of mercury barometer. The rise and fall of atmospheric pressure is indicated by a corresponding rise and fall of the mercury column in the glass tube. The standard sea level air pressure is given as 1013 millibar at a temperature of 15 degrees Celsius and latitude of 45 degrees north. This pressure is equivalent to 29.92 inches or 76 milliliters of mercury. Factors affecting air pressure. We have already seen that air has weight and therefore it exerts pressure. This pressure is not the same in all regions. Atmospheric pressure depends primarily on three factors. Number 1, altitude. Number 2, temperature. And number 3, earth rotation. Number 1, influence of altitude on pressure. It is a well-known fact that pressure decreases with an increase in altitude. On an average, the air pressure decreases at the rate of 34 millibar per 300 meters of altitude. The air pressure is low in the upper layers of atmosphere as compared to lower layers. This is because the air is composed of gases and thus is highly compressible. The lower layers of atmosphere are compressed and denser as compared to upper layers. Moreover, when air rises up, the molecules get farther apart and outward pressure decreases, whereas in the lower layers, in the compressed state, the molecules of air get close together and outward pressure increases. It therefore follows that when air sinks, its pressure increases. In sinking, the volume of air decreases, but number of molecules remains the same and they are in a compressed state. Thus, the outward pressure of these molecules is confined to smaller areas, hence the layer of air is dense. On the other hand, when air rises, its volume increases. As it expands, the air pressure decreases. Influence of temperature on pressure. Temperature is inversely proportional to pressure. It is because with the rise in temperature, air gets heated and rises up. As it expands, it creates a low pressure area. When the temperature is low, the air becomes heavier and denser. Influence of rotation of Earth on pressure. The rotation of the Earth causes air at the poles to be pushed towards the equator. There is high pressure on the poles because of low temperature. Because of rotation, the air coming down from poles occupies more space as it expands and this pressure falls. These low pressure belts are along parallels of 60 degree north and 60 degree south. Also, air always moves from high pressure areas to low pressure area. Therefore, as air moves away from poles, air moves in from the high level to take its place. Coriolis force and this effect. If the Earth did not rotate on its axis, wind would follow the direction of the pressure gradient. Instead of Earth's rotation produces the Coriolis force which tends to turn the flow of air. The direction of action of the Coriolis force is stated in Faraday's law. Any object afloat moving horizontally in the northern hemisphere tends to be deflected to the north right of its path of motion regardless of the compassion direction of the path in the southern hemisphere. A similar reflection is towards the left of the path of motion. The Coriolis force is absent at the equator but increases as we go towards the poles. And with this, I am ending my today's class. Goodbye.